All right, hello. This is a proposal for a new proof. I'll walk through some steps on it, but we'll go to the next step. And thanks for the introduction on it. No need to say anything further on here. I do a little bit of radio hobbying and the smart gardening stuff, which does play into this. I also work with big radio, but I really enjoy the open source side of security and deploying some tools for that. Yeah, and the QR code is the email if you guys were interested in contacting. So the overview of this problem that arises out of here is the idea of proof of habitat. What does that really entail? What does a habitat really mean other than something like an environment through there? I'll explore different solutions in there. There are some already out there, so I had to look at a little bit of those. But it comes down to one signal that's coming out of it, which is our fingerprinting. So if you're familiar with that, you might find this pretty smooth. And then actually how to flesh out something like proof of habitat. So what does that look like? And then some technical solutions and any kind of POCs out there. So this isn't demonstrating a POC going through there, so it's even up for grabs for the hackathon coming up and whatnot. Meme on the side here is giving the kind of idea of what proof of habitat is. If you played any video game that's an MMORPG, you have the fog of war idea. So you see only so far beyond you, and you can't see something behind the fog. So proof of habitat is really trying to keep that fog in place and making sure that nothing else can see beyond this fog of war. So currently, well, I got a little bit of inspiration from B-Sides last month. It's a security conference. Most major cities in Europe have a B-Sides, and Prague was last month. But there was one talk by Marina Bochenkova from Buzzword to Battlefield, Cybersecurity Challenges of Smart Cities. And so this was a talk all about how vulnerable open data systems are within cities. Prague even has opendata.praha.eu, I think it is. And I think she was also using a case study from Amsterdam. And so I also looked at some of the Amsterdam stuff available there, Bluetooth beaconing, and seeing how even Rijksmuseum uses some Bluetooth beaconing within museums and trying to place where people are located at within a museum to have an immersive experience. We also explored some of that when I was working with some collectives, Diffractions and SDBS. We put on a series of workshops taking place during COVID times of trying to make sure that we could do some remote stuff and make them work. A lot of it also came from this social physics idea. I don't think it really picked up, but Alex Pentland wrote a book about social physics, and it's really about how to measure people moving within cities. And I'll get more in depth to what that looks like. Actually, there's a good grid on the right which shows a little level of foot traffic, which is really related to the social physics side of things, and trying to categorize it, and mostly from the Google perspective of how to profit off of it in some way. And the last part is some IED detections, and then like drone warfare 2.0 and kind of the stuff we might be seeing in Ukraine currently. So we'll go over some little parts of that, but a lot of these came together to understand what proof of habitat really might mean on an RF level. Problems with current systems is the current mapping is pretty centralized. There are decentralized solutions for that. Some of the open projects out there, like OpenStreetMap, are accessible, peer sourced, and people do contribute to these data sources. However, it's largely used in centralized ways in big data models. So the software side of things are really centralized. Even UNESCO has some systems for that, monitoring environmental protection and things like that. That's where the habitat kind of comes out of. And then on the hardware level, there's satellite systems that are involved in a lot of these systems even use GPS or use latitude, longitude coordinates for anything. So there's other models even in the Web3 space that use coordinates and things like that. But a lot of that comes down to dependency on satellite systems. Mapping software itself that really works well with a good user experience is the Google Maps and Apple Maps, which is pretty dominated by them. Some of the problems trying to troubleshoot this is with non-standard mobile OSs. Like if you're working with graphene, you might notice that a lot of the apps don't really work with any of the the mapping software stuff. They need Google Play services or Apple Maps somewhere in there. And then generally how Google works and how Apple works with the maps, they don't rely on GPS in all cases. They can, but it's not as accurate inside the room if you need it. So what Google and Apple have really pioneered through there is our fingerprinting. They do this in a massive way, and it's how to infer a very precise location for a person in different places without the use of some kind of beacony tracker from a satellite. So I kind of built on that. Looks like there was a skip there. Yeah, so open projects like this, there's a lot of different layers involved in there. They have different segregations of these databases, so you can segregate it out and have different points in them. But a lot of times they need to be centralized and standardized in a way so that people can use them across different platforms, and that's largely the OpenStreetMaps side of things. They work with this the software of GIS or ArcGIS, if you guys know GIS, it's a mapping side. OpenStreetMap is community-driven as well. There's a lot of editing opportunities there, but there's different sources through there. So the mapping kind of problem is not too problematic. Like you can decentralize it. You do need to follow standards, but since that's quite open, you can always take these mapping softwares and put them back in the system. So that wasn't so much of an issue for that. Satellite systems are mostly aligned with nation states. We know that. I did put a little graph in here for CubeSat, so there is an open source satellite construction way you can do it, but you still rely on somebody else's rockets to get them up in space. So with SpaceX, it's a big venture towards that, moving away from nation states, but there's clearly some alignment in how that's done on the private world as well. So can you really decentralize this mapping? You can make it open, and you can crowdsource it. Many might bring up using Waze rather than Google Maps, but in the end, Waze is a proprietary of Google now too. And if you might see some of the integrations with those, they're using the peer source coming out of Waze to influence Google Maps. So you can't really escape it on that level, and if Google hears about it, they might go gobble it up and try and merge. So who really controls all that data? It does come down to a few. So trying to find a way that doesn't really gravitate the big data models to you was part of this proof of habitat as well. Is the decentralization really possible in it? A lot of it, well, I'll outline in the next steps of it might be possible, and you kind of work in a dark forest mode through there. The hardware side is also, on the mapping part, there are dependencies on the hardware to actually map it, and so you need to have validated cameras and trustable agents walking around and taking pictures and be able to get that. Google Maps and Apple Maps are quite full and complex on how many different data points you get out of it, from Google reviews contributing to it. But there's even a step here showing the rise in crowd or foot traffic around in the area. And there's a lot of data points that they pull in that. So trying to reduce that out, reduce dependencies on that, even as a user. I don't necessarily need to know when all these hours are unless I'm really going down there to buy a coffee or something like that. But it's not open during the evening, so it's data points that I don't need. So there's different parts to it. And they combine quite a lot of things. And when you do allow that GPS to participate in there, you're also contributing your data point, or your phone is participating in this whole data network. But yeah, traffic updates is another really important one. Can you crowdsource that one? It's proof of habitat doesn't quite work on that, but I'll cover some of that, I think, in the next part with wardriving. Wardriving is a pretty obfuscated term coming from 1980s movie on that, but Matthew Broderick was in the film on that. It comes from that, but it's really just about driving around and collecting people's RF points, and most of it's associated with Wi-Fi. So on the two left sides, you see some wiggle.net screenshots. I always like jumping into these at different time frames. You can see our venue right here. You got quite a lot of Wi-Fi hotspots moving around in the top end of the market space here, and that up in the top corner is Alta. So they're like a check Amazon kind of space, so you can just see a lot of that already picked up. You can know the SSID of them as you scan them and go through that. Wardriving is quite fun with some of that. It doesn't even make sense sometimes, as you can see in this big one. You have big long paths going there where somebody's picked up Wi-Fi points from airplanes. It's always nice to look at also war zones with this kind of stuff in the context of wardriving, because there is open data on that stuff. You can see kind of a pretty big blank spot for Ukraine up there, meaning that it's either, well, closed down by wiggle.net. On the right is Cell Mapper, and so you can pick up different cell phone traffic based on where the towers are located and based off of service and network. So specific networks, like in East Ukraine, Southeast Ukraine, have very specific service providers. Another fun one right now is also the Balkans, or seeing how that's changed since the 90s, and different domain infrastructure in there. So it's pretty nice to go through and see those changes. I think I did a recording of the same screenshots 4 years ago, and seeing how those service providers changed in East Ukraine with Phoenix and Lugacom networks. It's a big data security, privacy and security concern across there. This data is collected, it's open. You're broadcasting that data out there if you have a router out there, and there's not a lot of ways to hide it, even if you put your router in hidden mode. So be quite conscious of how you put your Wi-Fi SSDs out there, because they can be picked up from the street pretty easily, no matter if you're in an airplane and stuff like that. And this is the root of how our fingerprinting happens from the Google side, is picking up all these little data points and understanding that your phone is also participating in this network. So they pick up all these parts and understand it. Wardriving and wiggle.net thankfully make that publicly accessible with an account. I think they're pretty rate limited now, but it used to be quite open. And they use some mapping on the top there. You can see some of the mapping software used in there on the bottom with Esri, which is an open GIS system as well. The R fingerprinting, when that happens and how do you get into that system and opt in, are those settings that you see on your phone if you're using Google or Android or iOS. You have the options on the side here. Turn it on and off, but most people might accept the precise location. They don't tell you what you're taking out of it. They don't say what it means, but that precise location means taking in all your data points and communicating with other people who have jumped into that network. So that's how the user experience, but the rest is being able to see traffic and seeing foot traffic analysis in different locations and having those updates, and you're participating in that. It's a useful thing in some cases, so our fingerprinting also used in security world. This is a POC showing on the left here, and using it only in a specific environment, say an office, and understanding when a new SSID or a new router comes into play, or a bad actor comes in. So you can use our fingerprinting to map an environment in a very small scale, and then understand if there's a change to that rapidly. So if you're in a concrete building, there's a lot of chances to really have a consistent RF fingerprint in there and be able to see that kind of stuff. It's not the routers themselves that are, well, they're participants in it, but there always needs to be some control or centralized reader on that, so you can see that there. Proof of habitat, so back to the point on here. It's a proposal for a decentralized protocol using RF fingerprinting only. There are a couple other protocols out there that utilize RF fingerprinting, so it's not unique in that sense, and I'll go over those. It's passive, so it picks those things up. It doesn't require GPS. It should not involve GPS at all. I put human oracles in there because of the proof of attendance as well, so it kind of contrasts with that. It stores data locally, so that you can do things all local there, and it's local first. The other exploration on that is understanding how to really protect that data, so ZK proofing is some of the routes I would take on that. I compared it to a routing table, so if you have a routing table, it measures those hops between, I think even on the last talk was mentioned the hops between. So it's kind of like storing that table, but not just hops, but your distance from other locations and whatnot, and making that a little bit more readable, accessible, and then private. Why habitat? Yeah, that's a good question on that part that I asked myself here. But habitat is not just about the green environment or the biological footprint around. I use that on that side. But RF is also part. So you can go to the middle of the forest and you can collect an RF fingerprint and understand which planes are passing through at a given time, maybe what satellites are beaming down ahead. Some of it started with trying to understand, on the smart gardening side, how to relay things across plants. And so I read an article once about pine trees with the tannins in the sap being able to have some kind of radio blocking, but also transmissible. So I don't know if you've ever seen that potato experiment with using a potato for a Wi-Fi router. But there is a lot of chances there. Actually, maybe it was mentioned back there. So there's a lot of biological side to that, but there also, you can understand interference in an environment by the radio fingerprint. So it can be used in that sense as well, and preservation and conservation organizations can also use it to figure that out and understand if there's too many people going into a spot. Like I think of people in, it's a big problem in California is when there's springtime and all the flowers are blooming, everybody goes to the same location all at once and flood it and trash all the flowers in the fields in the mountains. So it could be used for something like that. Why it's different than proof of location? Proof of location, I learned, also uses quite a lot of that. They use RF fingerprinting. It relies on specific devices. So they pushed out a lot of different devices. FOAM is one of the main ones on that. And then they lock in the packet at a global coordinate. So they use the latitude, longitude to go into that. And they are using it in cities. So it's really, I think it's in New York where the first tests were done. But they use the coordinate as the block. And so once it's locked in as a coordinate, you're using that system. So that system wouldn't work on Mars, for example. And that's not mainly a concern here, but proof of habitat is really trying to get down to a very local level. It uses relativity, so your distance between other devices. I'll share a packet structure in the next slide on that. It's really about privacy and you being able to control that. So if you have a proof of habitat proof there, you're not going to be sharing that outside of your area. And it goes on that small network. Community control is really key. Trying to get away from these kind of hub ideas or having another specialized device is really hard. I think that's where proof of location came across, and they tried some of that with proof of attendance as well. Proof of humanity also comes up with this. If you're trying to validate with other things across with other humans, if they have a mobile device or not is a question. The main point on the proof of habitat is that it's designed for the privacy-focused, community-driven mapping part and the local wayfinding. So how do you find your space between 2 points that are really local to you and not go beyond that? From the top down, the device would collect RF signals from nearby beacons or other devices that are participating, and then would create a local proof of that relative location compared to those other devices. Not necessarily where it's at in the world, but every location has a unique habitat where our fingerprint is really unique, and it might change if a plane is flying by, but overall they're quite stable, and largely might be due to cell towers are quite immobile. So cell towers come up and you can utilize those, and that's what Google uses a lot of. In this case, the proofs would be stored locally on the device if the operations are done there. The zero knowledge proof on top of that would probably add that level of privacy, depending on the compute power available. Then I did compare it to that routing table, but mostly about the hop distance. So I think the next slide shows after that. So there is some issues going forward with how is this blockchainable or ZK might provide some privacy level to it. The intention on it is it's local first, and so that doesn't go outside of what's needed. But you could distribute a blockchain across through that. Ideally working with mesh networks. So if anybody's worked with mesh networks before, working with that. And if you've worked in mesh networks before, you know how problematic mesh networking can be for sending size of data and stuff like that. So being as local as possible, integrating with something like Briar. I think somebody mentioned that on a chat yesterday. Most of the proofs on that should lean towards that privacy, and then being able to validate between two people that have connected before or two devices that have connected before. is one part of that. The main side of it is being optional in the level of RF fingerprinting you're contributing. So having control of that, being able to say no to, I don't want GPS to be a part of it, and that doesn't become part of the block or the package. The structure I suggested on here is a packet like this, so having your timestamp, and then each piece of it being some kind of UID or obfuscated side between nearby devices. The main part about satellites being accurate on what they do is being able to triangulate and take 3 locations, so 3 satellites to be able to get that. The same thing happens with RF fingerprinting, so you're able to define that. So with 3 devices at minimal, you can find the exact location relative to those other 3. You understand it can be quite complex with moving devices and stuff like that, but if you can utilize the cell towers and bounce off of those are pretty static. I added some other parts to it, so having an option to put your source device in there to contribute to that, but if you're passively going into environment to control something like the biological environment, you might not need the source device itself, other than knowing whether it's a static device or mobile. So that RF medium's the type of that, and utilizing stuff like Bluetooth and Wi-Fi 802, any other standards in that. And then an overall RF environment analysis or a spectrum analysis. So if you work with HackRF or any kind of tools like that, you can get a whole scan across, but maybe waypoint on specific RF frequencies. Use cases, and I think I'm 3 minutes out, so I'm going to fly through that. If used, some of the use cases through here was, I thought about people in cities or people in forests, etc. If you've used Suki before, it was a crowdsourced, very local first, location-based thing for demonstrations, and mostly to avoid getting kettled by police in a certain direction and being able to communicate quickly through that. So Suki was one of the inspirations on this. It doesn't have to be a mobile phone. We could reduce the hardware itself to even an ESP32 or stuff like that. So there's been similar solutions in the Occupy space since 2017 as well. You need to be able to monitor the habit changes with sensor networks. So if you establish a perimeter, and that goes down to even a war zone situation, so the next one, being able to interpret when a new drone comes in and detect those kind of things quickly. So if there's a interference within your radio perimeter, to be able to detect that drone and then start to mitigate for it. Ukraine, it might be a little too fast, but already different sides are utilizing fiber optics only to bring drones in across the border, mostly because you can block the RF signal. And then utilizing this kind of proof of habitat to validate locality-based data requests. So that goes back to the open city situation. And so if somebody across the world wants to access data in one location, they probably, well, right now they can, if it's locked in some way, you can log in with a VPN and change your IP address and try to get that, but having some kind of proof of location there, or proof of habitat in that case, would help validate whether that person has the reason to access that data. Challenges and steps, so the big one is jammers. That's always the case. Spoofing, and then hardware vulnerabilities, of course. So ESP32 chips, for example, are quite vulnerable, and you can find different workarounds with that. Mobile phone technology is always growing. And then how to spoof that. The real proof of habitat is really to not allow spoofing of a location. So if you use proof of location or coordinate-based stuff, you're going to be locking in a latitude-longitude coordinate, and that kind of can be redone or spoofed in a way with a different timestamp. Whereas proof of habitat, it's not as easy to spoof your relativity to other things in that sense, and it's much more localized. Community hubs as relay points. There's been some experience with the collectives before as well of leaving some kind of community router around or some kind of device to be able to check in, some kind of server to go into. Well, those need to be ran and maintained, and nobody usually picks those up for long term. So community hubs might not be an option in the future on that one, but hopefully we have a better stake in that. Zero knowledge proofing on that to be able to be done locally is pretty difficult with the compute power you need on that. And most of it is just a proof of habitat. The main focus on there is to allow and enable local first digital ecosystems as the primary layer for that. And then there's the security side of it with robust radio frequency signature or radio fingerprinting signatures. So having trusted routers, and there's some experience in that. The whole side of it is to try to help foster and create dark forests and be able to have different communities operate on a local level first as much as possible. And that's my time.
So thanks a lot, Casey, once again from my end. And if you guys have any questions, feel free to ask. Okay.
Hey, thanks for the talk. So I have two questions. One, if one wanted to prototype this in a physical location, what would you suggest to use? And the second one, would a LoRa mesh network be a good way to apply something like this?
I haven't thought about it at first with Aura, but right away, Bluetooth is pretty manageable within a small space to be able to prototype it. Wi-Fi is acceptable and you can gather that, but I would suggest setting up different routers in different locations and using those as kind of a static location to get the RF fingerprinting first. I worked with a hack RF more on that, but a mobile phone should be capable of taking those readings as well. So everybody's walking around with a mobile phone in their pocket with all the sensors available, and they keep adding more that maybe are unused. Kind of like using 10% of your brain, you're using 10% of the sensors available on your mobile phone, and big data is using the other 90% now.
Is there any other question? Please feel free to ask, don't be shy. So I have one question, like in that slide, challenges and everything, it was what was the network? So what exactly does that mean by that?
Where at?
Yeah, mycelial network.
Mycelial, yeah, the quote down there is understanding how a fungus network works under trees. And so, well, dark forest is a common term here. I think it was used a lot more last year in the ETH Prague. That were all kind of dark forests around there and isolated networks and silos. A mycelial network works underneath the trees to allocate resources back and forth. And then sometimes you don't even know when you're walking into an area whether you're walking on a mycelial network. And I think there's a lot of cases in, especially West Coast US, of finding large organisms across. So just trying to find that hidden signal underneath the dark forests that can actually link them, or link a dark forest where otherwise we wouldn't see a forest at all, we'd just see several different trees. So the mycelial network just represents that undertone there.
I think it's kind of symbiotic relationship in a way.
What's that?
Symbiotic relationship?
Yeah.
Okay, that's cool.
Yeah.
Okay, so thanks a lot again, Casey, for your wonderful talk. And thanks a lot, everyone, for being a wonderful audience. Give a huge round of applause for yourself as well.